Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 88. So it says photons of energy 9 electron volts are incident on a metal. It is found that current flows from the metal until a stopping potential of 4.0 volts is applied. If the wavelength of the incident photons is doubled, what is the maximum kinetic energy of the ejected electrons, and what would happen if the wavelength was tripled? Okay, so first find the work function from our given values here. So a photon energy of 9 eV corresponds with a stopping potential of 4 volts. So EV naught here equals HF minus the work function, or the work function is HF of the photon minus EV naught. So this is 9 EV minus 4 EV, gives us a work function of 5.0 eV. So if the photon's wavelength is doubled, so wavelength goes to 2 wavelengths, then the energy goes to 1/2 the energy because they're inversely related. So that means we now have an energy of 4.5 electron volts, and that's smaller than our work function because we already said our work function was 5 electron volts. So that means there's going to be no current flowing. So the maximum kinetic energy is 0. So K max here, 0 in this case. So again, if the wavelength goes to 3 times the wavelength, then the energy is going to go to 1/3 of what it was, which means the energy is now 3.0 electron volts, which is again less than the work function. So that means there's going to be no current. In both cases, no current and no kinetic energy.